Now, question 17. Polonium has an atomic radius of 167 picometers and is the only element with a primitive cubic lattice structure. Determine its density in grams per cubic centimeter, and I give you a little conversion there just to be nice. Alright, so a primitive cubic lattice structure is just a simple cube, alright, which means there's 1/8 of an atom in each corner. Alright, so it'll look something like that, where in each of those four corners you have 1/8 of an atom, and there are 8 corners altogether. So just like before, 1/8 of an atom times 8 corners is 1 atom. Okay, that is, there's 1 atom per unit cell. All right, now what we need to do is find the mass and divide that by the volume. Okay, so the mass of 1 atom, and then we need to find the volume of that unit cell, okay, which is where that 1 atom is. The 1 atom per unit cell, the volume of the unit cell, we find the mass, divide that by the volume, and we'll get the density. Okay, so first of all, the atomic radius is 167 picometers, right? So that is this distance here, 167 picometers. We have the length of one side of the cube is twice that distance, so that will give us 334 picometers. Okay, now we're going to cube that value to find the volume of that unit cell. All right, but first I'm going to convert this into centimeters. I think it'll be slightly easier that way. So we're given the conversion factor. 1 picometer is 10 to the minus 12th meters. Okay, and we know that 1 centimeter is 1 times 10 to the minus 2 meters. Okay, so that difference between picometers and centimeters is 10 to the 10th. Okay, meaning there are 10 to the 10th picometers in 1 centimeter. Or you could say there's 10 to the minus 10th centimeters in 1 picometer. So let's just use this conversion factor, 10 to the 10th picometers to 1 centimeter. All right, and then so what we'll have is we're just moving the decimal place 10 places back to the right, rather to the left, and that gives us 3.34 times 10 to the negative 8th centimeters. Okay, so to find the volume, we're going to cube that, and I see I did not leave myself enough room for this problem, but we'll squeeze it in here somehow. So if we cube that number, let me write it like this: 3.34 times 10 to the negative 8th cubed equals, okay, so when we cube that, we will have 3.34 raised to the 3rd power, okay, which is 37.226. As long as we keep at least one extra significant figure, we should be okay. Now I just did the number, okay, that would also be, you would cube that times 10 to the negative 8th, which would give us negative 24, right? So it would be 37 times 10 to the negative 24th, or 3.7 times 10 to the negative 23rd. Okay, so 3.726 times 10 to the negative 23rd, and this will now be, I didn't show it there, but these are centimeters from here, and that's cubed because we cubed it. Okay, so there's my centimeters cubed. Now that's the volume. I just need to find the mass of the one atom, and I want that mass in grams. Okay, so if I look at the periodic table, I will find the atomic mass for polonium, and that is 208.98, and the units are grams per mole. Okay, so 208.98 grams per mole, and I'll put that down here. 208.98 grams per mole of polonium. All right, but I only have a single atom. All right, so that means I need to divide this by Avogadro's number, because it's this many grams in a mole of polonium, but I only have one atom. So 6.022 times 10 to the 23rd atoms per mole, for every mole of polonium. Okay, so my moles will cancel, and I'll have grams per atom. Okay, which I will then take and divide that by that volume. So what I end up with here, I'm just going to calculate that and write it up here. So if I put that in on the calculator, it shows okay, let's see, 208.98, and we're going to divide this by 6.022 times 10, which is the little e, to the 23rd. Okay, so that is the number of grams per atom of polonium. Okay, 3.47 times 10 to the minus 22. And I'm going to go ahead and include that extra 0 just for good measure. Times 10 to the minus 22 grams, and that will be divided by this value that I had here, 3.726 times 10 to the minus 23rd cubic centimeters. Okay, so I will divide that answer by 3.726 times 10 to the minus 23, and there is my density, 9.31. Now is where I would round that to 9.31 grams per cubic centimeter. All right, cm cubed. So that is my final answer. A little bit crowded for space, but that's how you work that.